So it tells us here, example 2 is to find an equation of a line passing through a point, 1, negative 2, and it has a slope of 3. So again, we have to know what point slope form is. So if you don't have it memorized, you're going to have it memorized for the test. This is one that, again, if I know it, then you have to know it. That's one I have memorized. So again, this is the point slope form of a line. Y minus y1 equals m times x minus x1. Right here, the ordered pair gives me my x1 and my y1. And the slope is 3. That would be my m. If you remember yesterday, I told you the big thing is there are built-in negatives that you have to account for. So when I substitute in, I have y minus y1. So that would be y minus negative 2, which we write as y plus 2. Remember, minus a negative is the same thing as adding. Equals m, which is 3, times x minus x1, which is 1. So now this here would be the equation of a line in point slope form. Now what if they ask me to put this into slope-intercept form? All right, so what does slope-intercept form look like? Y equals mx plus b. So what do we notice about slope-intercept form? The y has to be isolated. We have to get the y by itself. And we also notice there are no parentheses. So to go from point slope form to slope-intercept form is actually kind of easy. All we have to do is distribute our slope. So that's going to be y plus 2 equals 3x minus 3. And then we want to get y by itself. So y is being added by 2, so we subtract 2 from both sides, which tells me y equals 3x minus 5. So again, both of these are equations of a line. The top one is in point slope form. The bottom one is in slope-intercept form. You see, we knew it had the point 1, negative 2, and it had a slope of 3. So we should be able to rise 3 and run 1, and we're still on that line. But we also see once we put it in slope-intercept form that it should have a y-intercept of negative 5. Which it has that as well. Right here, it crosses the y-axis at negative 5. So it fits both criteria in both point slope form and slope-intercept form. Y equals 2x minus 13. What do you guys think? I haven't worked it out, so I have no idea. Y'all think that's right? Okay, that should be our point slope form. And if I distribute, y plus 7 equals 2x minus 6, which says y equals 2x minus 13. I agree. Okay, so the first special case is if we have a vertical line, which is a line that goes straight up and down. Because why would point slope form not work for a vertical line? It does have slope, but the slope is undefined. So we can't put a number in for m because undefined is not a number. So when we have a vertical line, point slope form will not work. So does anybody know or remember what the equation for a vertical line looks like? Close. No. No. All right, so let's think about a vertical line very quickly. X equals K, that sounds like a real fancy definition that you'd find on the internet. So if I had a vertical line right here, all right, what are some of the points on this line? So what would this point be? 3, 1. And what would this point be? Let's say that's 3, -2. And then what would this point be? 3, 0. What do we notice about all points on a vertical line? The x is the same on all of them. So can't we just say that, like for my example here, x equals 3? And so it's the collection of all points where x is 3. So vertical lines always have x equals some number, and that is their equation. There is no slope. There is no y value. It's always x is equal to a number. So now my other special case, we actually can use point slope form for this, but we don't have to. It is a horizontal line. So if vertical lines say x equals a number, what do you think a horizontal line is going to look like? Y equals a number. Because again, if you think about it on a graph, if I were to draw a horizontal line, say that that's at 2, then every y value on that line is 2. Now, why will point slope form work for a horizontal line? Because it has a number representing its slope, and that number is 0. So think about what would happen. So say I picked a point here. So let's pick this point. So that's the point 1, 2. And we know that the slope of the green line is 0. So I would have y minus y1 equals m times x minus x1. Okay, what's going to happen here? 0 times x minus 1. It's going to just be 0. So I've got y minus 2 equals 0. When I get y by itself, y equals 2. So I just have y equals a number. There is no x value. Wow, great question. So it tells me what my y value and my x values are. So think about an ordered pair. Now what is the x value? What's it representing? It tells me x is the year, and it tells me the y value is the revenue. Do we know what revenue is?
No.
How much money you make? What's your revenue? Can't you look, man, those words look great up there. That's revenue is in the y position. So year and revenue. So I've got 2 ordered pairs because I have 2 years that I'm looking at. So we've got to make 2 ordered pairs, given the year as the x, the revenue for the y. So let's make our first ordered pair. You see, read the question. Comcast had a revenue of $68.775 billion in 2014.
All 10th grade, last name A through M, to go to the high school library at this time for your pictures.
So the year is 2014, and then the revenue is $68.775 billion. So that's my first ordered pair. Now my second ordered pair is in 2015 is the year, so it's my X. And we have 74.510 billion for my Y. So I have 2 points. Now in the end, what's it asking me to do? Write an equation. So we've been working on point slope form. So if I can put this in point slope form, I could write an equation. So I need to know the slope. So we're going to put into the slope formula y2 minus y1 over x2 minus x1. So I can see my change in y is going to be 1. Now my change in x It's going to be 74.51 minus 68.775, which is 5.735, and that's million. I'm sorry, billion is my slope. So now I know the slope, and now I can use a point. So I'm going to choose the first point. Now it does not matter which point you choose, you just have to pick a point. So knowing the point and the slope, I'm going to put it in point slope form. Y minus y1 equals m times x minus x1. All right, somebody get a calculator. So we've got y minus 68.775 equals 5.735x minus 11550.29. Somebody double check me. Okay. Oh, that's good. Well, I didn't do that in my head. So now I'm going to add 68.775 to both sides. So it tells me y equals 5.735x minus I got 1. That's not right. One four. Oh my gosh! I hit equal twice. Did somebody get it? I got 11481.515. Yes. Somebody back me up. Y'all have no idea. Y'all are just saying yes, just so I'll go on. Okay. So here's my equation. That's the first part. Now the second part is make a prediction for 2016. So now x is going to be 2016. So I'm going to plug that in. Y equals 5.735 times 2016. Then I have to subtract 11481.515, which gives me a value that y is going to be equal to 80.245. And again, this is in billions. And I keep writing millions because I can't believe somebody can make that much money. But hey, when you own a theme park and all the internets, that we're going to look at when we get to this chapter all about parent functions. It says in the next section we're going to be introduced to the precise meaning of what a function is. The simplest type of function is the parent linear function. So it looks like f of x equals x. So basically we have an x to the first power and a y. And those are my only two variables, and they're both to the first power. It says, as its name implies, the graph of a parent linear function is a line. The basic characteristics of parent linear functions are summarized below and on the inside cover of this text. Okay, so again, any graph that is a line, its parent function is this linear function f of x equals x. Okay, so when you look at this, do any of those words look familiar to you? Which ones? Okay. Okay, so what is the domain? Does anybody remember what domain is? Yes. The domain is the list of all possible x values that the graph takes on. So when you look here, the x's go all the way to negative infinity up to positive infinity. The x's go on forever. So the domain is, this is all real numbers.
Excuse me, teachers. I need 10th grade, last name N through Z to go to the high school library at this time for pictures. 10th grade, last name N through Z to go to the high school library at this time for pictures. Thank you.
So, have y'all seen infinity sign before? The sideways 8? Okay. So that's all they're saying. The x's are all the way from negative infinity up to positive infinity. They go on forever. The range, that's the list of all my y values. So again, same thing. The graph goes down forever and up forever. So the range is all real numbers, which is from negative infinity to positive infinity. The intercept, that's where it crosses the axis. How do you say multiple axis? Axes. How about that? Real fancy. Axis. I like axes. That's what it should be, like syllabi. Anyways, so here the only time we cross an axis is at the origin. So its intercept is at 0, 0. And the last thing it says is the function is always increasing, because as we read this from left to right, it is always going up. So it is constantly increasing. Okay, so we're going to be now sketching graphs of lines. Many problems in coordinate geometry can be classified in two categories. Given a graph, or a part of it, we want to find its equation, or given an equation, sketch its graph. So you see how we're just going back and forth. If I'm given the graph, can I find the equation? Or if I'm given an equation, can I sketch the graph? For lines, the first problem can be solved using the point-slope form. This formula, however, is not particularly useful for solving the second type of problem. The form that is better suited for graphing linear equations is slope-intercept form, which again, you're going to be very familiar with. Slope-intercept form is just y equals mx plus b. So again, if you've never seen that before, I don't know how you got to my class. That'd be amazing. Okay, but right here is the slope-intercept form of a graph. Y equals mx plus b, where m is the slope and b represents the y-intercept. That says we can practice an interactive version of this graphing. Well, I tried clicking it and it didn't work for me. So I mean, it worked, but then I had to put in a textbook and it didn't work. So I think that those are going to be useless. So let's look at the question then with just pencil and paper. It says determine the slope and the y-intercept of each linear equation, then describe its graph. Okay, so the first one, I've got x plus y equals 2. Can we identify its slope and its y-intercept right now? I cannot. Why not? Because it's not in slope-intercept form. In slope-intercept form, the y is by itself. So I'm going to take A and I'm going to get y by itself. So in order to do that, I'm going to subtract x from both sides, or I can think about moving x to the other side, and that becomes y equals negative x plus 2. Now, is this in slope-intercept form? It is. So first, determine the slope. What is the slope of this line? Negative 1. What's the y-intercept of this line? 2. So if you had to describe its graph, how would we describe it? Well, I would say it goes through the y-axis, or it has a y-intercept at 2. And then we could go down one to the right one to find the next point on the graph. So I just got done teaching my geometry class. They didn't know when they were graphing which one to use first. They had a big argument. Should they use slope first or should they use y-intercept first? I'm trusting that you guys in precal know which one to do first. Which one is it? Yes. The slope tells you where to go to find the next point on the graph. But you have to start with a point. The only one that's a point is the y-intercept. So we would plot this on the y-axis at 2. Then we could go down one, right one to find the next point on the graph. All right, B part. Is that in slope-intercept form? Okay, what did we just say? What does slope-intercept form look like? Y equals mx plus b. Is the y by itself? Yes. So is that in slope-intercept form? Yes. But that's also one of our special cases that we talked about earlier, where you have y equals a number. Okay, so doing B part, what is my slope? 0. What is my y-intercept? 2. So it crosses the y-axis at 2, and it has a slope of 0, because this is a horizontal line. So if you had to describe its graph, how would you do that? It's a horizontal line going through the y-intercept of 2.
I don't know.
You don't know?
Well, I got the slope is a half,
Okay.
and then the y-intercept is negative.
Okay. How did you find those two values? Did you say negative 2?
Yeah.
How did you find those two values?
I got the y by itself. Well, it was 2y at first, and then I divided both sides by 2.
You divided first?
Well, I got the y by itself, and then I divided.
So you moved the x over first? Or did you divide by 2 first? You did it right. I'm just wondering. I'm just curious.
Yeah, I got like, it was,
So if it were me, I would move the x over first, make it negative. And then y is being multiplied by negative 2, so I would divide everything by negative 2. So that tells me y equals positive 1/2 x minus 2. Like my general rule of thumb, when I'm solving equations, I'm going to get rid of the thing farthest away from what I'm trying to isolate. So if I'm trying to get y by itself first, the thing farthest away is the x. So I get rid of the x first, then next is the negative 2. And now I have it in this form, so it's easy to identify. Y-intercept is negative 2, slope is a half. So if I describe its graph, it has a y-intercept at negative 2, and then you can rise 1, run 2 to find the next point. Rise 1, run 2, rise 1, run 2. So how'd you solve this? What steps did you take?
Well, first I subtracted by 3x
Okay.
on both sides,
Okay,
and then I added 8 to both sides,
okay,
and after that I divided by 4,
okay,
and then I got y equals negative 3/4 x plus 2,
okay. So then what's the slope?
negative 3/4,
Okay, and the y-intercept.
2.
That's it. As from the slope-intercept form of the equation of a line, we can see that horizontal lines have a slope of 0, and they're in the form of the equation y equals b. And we've already talked about that. And then this is consistent with the fact each point on a horizontal line is through the point 0b, and it has a y coordinate. Similarly, each point on a vertical line through a0 has an x coordinate of a. So a vertical line has the equation of the form x equals a. So that's really stuff we talked about yesterday, our two special cases. This equation cannot be written in slope-intercept form because the slope of a vertical line is undefined. However, every line has an equation that can be written in general form. So here's the last form we're going to look at here. It's called general form. ax plus by plus c equals 0. So that last problem that I just gave you guys would be a problem that was in general form. I had 3x plus 4y minus 8 equals 0. That would be the general form of an equation of a line. So right here are 5 main equations of lines that this book is going to work with. We have general form, where everything's on the same side. We have equation for a vertical line, that's x equals a number. Horizontal line is y equals a number. Point slope form, y minus y1 equals m times x minus x1. And slope intercept form, y equals mx plus b. Now we're going to start looking at parallel and perpendicular lines. The slope of a line is a convenient tool for determining whether two lines are parallel or perpendicular. So what are parallel lines? How would you describe that to me? Lines that never touch, right? They always think about railroad tracks, right? How they go beside each other. So parallel lines are lines that never touch. And this says two distinct lines are parallel if and only if their slopes are equal. So just a quick lesson here on this phrasing, if and only if. This is something that they really say in math often, and that's really the only place I've ever seen it. What if and only if means is that you can read this in either direction and it's still true. In other words, it's a biconditional statement. So let me give you an example. It says, if two lines are parallel, then their slopes are equal. Do y'all agree with that statement? If two lines are parallel, their slopes are equal. I agree. It also means I could read it the other way. If the slopes are equal, then two lines are parallel. So it's saying it can go in either direction. I know you may think, well, that's pretty self-explanatory, but not everything is biconditional. They don't all work that way. So let me give you an example. My wife gets paid every other Friday. That's her pay schedule. So if it's payday, then it's Friday. That's a true statement. But if I switch it, if it's Friday, then it's payday, is not true. Because she doesn't get paid every Friday. She gets paid every other Friday. So that would be a conditional statement because it's only true in one direction. But a biconditional statement means I can flip it around. It's true either way. Anytime you see that if and only if, that's telling you you can say it in either direction and make that statement true. You probably didn't know that. You may not ever need to know that. But if you go into higher level math, you use that a lot when you're dealing with proofs. So anyways, what's this telling me? If I have two slopes that are the same, the lines are parallel. Or if I have two lines that are parallel, the slopes are the same. So it tells me to find the slope-intercept form of the equation of a line passing through a point, 2, -1, and parallel to the line, 2x minus 3y equals 5. Okay, so I have to find the equation of a line given a couple of things. I know that my line has to go through this point, and I know that it must be parallel to this line. Okay, let's start with the blue statement. What does it mean if my line is parallel to that line? It means they have the same slope. So I'm going to take what I have underlined in blue and find the slope. That's my first step I'm going to take. So in order to find the slope, I must get this in slope-intercept form. So I've got 2x minus 3y equals 5. I need to get y by itself. So I'm going to subtract 2x. That's going to leave me with negative 3y equals negative 2x and a positive 5. Now y is being multiplied by negative 3, so I divide everything by negative 3. And so that's going to tell me y equals positive 2/3 x minus 5/3. So again, let's don't lose sight of what we're doing. My line is parallel to this line. I know this line has a slope of 2/3. That means my line must have a slope of 2/3. What else do I know about my line? My line must go through the point 2, -1. Okay, so what all information do I know about my line? I know a point and the slope. I know a point and the slope. Yes. So I'm going to put that in point, slope, form. So that's going to look like y minus y1. So that's going to be positive 1 equals m times x minus x1. Now, if it asks me for an equation for my line, I'm finished. But what does the question ask me again? It wants it in slope-intercept form. So I put it in point-slope form. Now I need to convert it to slope-intercept form. So to go from point-slope to slope-intercept, we distribute. So it's going to be y plus 1 equals 2/3 x minus 4/3. And then we're going to subtract 1 from both sides. So that's y equals 2/3 x, and that's going to be minus 7/3. So you can put that in your calculator, or you could get a common denominator in your head. So minus 1 means minus 3/3. So I'm subtracting 4/3 and subtracting 3/3. That's a negative 7/3. So now I have found the equation of a line in slope-intercept form.
Y equals 5/3x plus 23/3.
What do you guys think?
Yes.
Do I need to work through this one? Okay. So first, my line must be parallel to this line. So I'm going to take 5x minus 3y equals 8. If it's parallel to that line, it has the same slope. So I need to find the slope of this line. So get it in slope-intercept form. So I subtract 5x. That tells me negative 3y equals negative 5x plus 8. Now divide by negative 3. So that tells me y equals positive 5/3 x minus 8/3. I know you can't see that. Give me just a second. So again, if my line is parallel to this line, then I know it has the same slope. So my line slope is 5/3. Now I know the slope of my line, and I know a point on my line. So I'm going to put that into point slope form, which is y minus y1 equals m times x minus x1. So that's minus negative 4 is plus 4. Then we distribute. So that's going to give me y minus 1 equals 5/3 x. Then 5/3 times 4, that's going to be 20/3. And I need to add 1 to both sides. So that's y equals 5/3 x plus 23/3. Which is what Joe said. Just take a minute to review what is an opposite reciprocal or a negative reciprocal. Well, if I have a number 3, an opposite reciprocal means I'm going to change the sign and flip the fraction. So I can think 3 is 3/1. So the opposite reciprocal would be negative 1/3. The opposite reciprocal of negative 2/3 would be positive 3/2. These are slopes that are opposite reciprocals or negative reciprocals of each other. We change the sign, we flip the fraction. And that's for perpendicular lines. Given line. So it's very similar to the last kind of problem, except now I know that we are perpendicular to this line. So if it's perpendicular, it has an opposite reciprocal slope. So the first thing I want to do, find the slope of this line. So I'm going to copy down the equation, and I'm going to get it in slope-intercept form. So I subtract 2x. That tells me negative 3y equals negative 2x plus 5. Now I'm going to divide everything by -3, which gives me y equals positive 2/3 x minus 5/3. So now what do I know? I know that my line is perpendicular to this line. So if that line slope is 2/3, my line slope is -3/2. It's the opposite reciprocal. Change the sign, flip the fraction. Now it follows the same pattern. I know the slope and a point. I'm going to put it in point-slope form. Y minus y1 equals m times x minus x1. I distribute. That tells me y plus 1 equals -3/2 x plus 3. Yep. And then subtract 1. So that's going to give me y equals -3/2 x plus 2. So that would be an equation in slope-intercept form of my line.
So
What'd you get as your answer?
y equals -3/5 to x minus 7/5.
Minus 7/5? What do you guys think?
Yeah.
I haven't worked it out, so I'll agree if everybody says yeah. Do I need to work this out? Anybody need to see this? Okay. So let's do it. Okay. So here is the equation of my line. And I know, or not my line, the equation of a line. And I know my line is perpendicular to that line. So I have 5x minus 3y equals 8. So I need to get this in slope-intercept form. So I subtract 5x. That's going to tell me -3y equals -5x plus 8. And now it's being multiplied by -3, so I divide everything by -3. That's going to give me y equals positive 5/3 x minus 8/3. Now my line is perpendicular to this line, so that line has a slope that is 5/3. That means my line must have a slope that is the opposite, so it's negative, reciprocal, 3/5. Everybody good so far? Now, here is the slope. Here is a point. So I'm going to put that into point-slope form. Y minus y1 equals m times x minus x1. So minus -4 is the same thing as +4. And solve. So I distribute. So this is -3/5 x minus 12/5 is y minus 1. And then I need to add 1 to both sides. So that's going to be y equals -3/5 x minus 7/5. Because they have different signs, subtract, keep the sign of the dominant number. So when they're talking about relationships, they're talking about parallel or perpendicular. So are any of these lines parallel?
Yes.
Which ones?
The first one, the second one.
So y equals 2x and y equals -2x are parallel?
Yeah.
Joe doesn't think so.
Well, Joe don't think so. I'm wrong.
Why not, Joe?
2x and -2x are the same thing.
Oh, so to be parallel, what has to happen? They must have the same slope. That's why I told you, make sure you understand what we're talking about, what we're going through. So none of those have the same slope, so none of them are parallel. Are any of them perpendicular? Which ones? Second one and the third one. Y equals -2x and y equals positive 1/2 x. We would say those two are perpendicular because they have opposite reciprocal slopes. One is positive, one is negative, and they are reciprocals of each other.